Hey guys, so we are in Unit 5, okay, which means we are almost done with first semester. We just have one more unit after this, and so it is going to be all about bonding, how atoms create bonds between each other to form molecules and formula units and just do all those sorts of things. And so a bond is a force that holds atoms together, and these atoms bond because they want to achieve a stable configuration with 8 valence electrons. And we've talked about this before as following the octet rule. That's something we've been talking about for the past couple units. And so there are two main types of bonds. So the first type is an ionic bond. And so an ionic bond forms when one atom transfers their valence electrons to another atom, and it's usually between a metal and a non-metal. And so this results in one positively charged atom, which we call a cation, and one negatively charged atom, which we call an anion. Okay, and those are vocabulary words from previous units that you should already know. And since we know that opposite charges attract, this is what forms that bond, is the attraction between the positive and negative charge. And so properties of ionic compounds, which an ionic compound is made through ionic bonds, is going to be similar to those of metals that we learned about in our Unit 4 periodic table, and that's because they contain metals in them. And so one thing is that an ionic compound is also known as a salt. Okay, and so it's not just talking about the salt that you put on your French fries, but any ionic compound can be called a salt. And so a single entity is called a formula unit. And what I mean by that is if I have NaCl, which is table salt actually, NaCl, NaCl, I have 3 of those, that would be 3 formula units of NaCl. Okay, 3 individual units of them. And so they exist as a solid at room temperature. They easily dissolve in water, and they have high melting and boiling points. And so with that, they also easily conduct electricity in solutions, and they have high electronegativity values. And we'll jump into that more, but remember that electronegativity is the ability to gain or attract an electron, and we learned about those when we talked about our periodic trends last period, or excuse me, in our last unit. And so some common ionic compounds are NaCl, which is table salt, what you would put on French fries. Another one is MgCl2. Okay, that's called Epsom salt. It's what you put in your bath to relieve sore muscles. Okay, and so that's kind of a summary of ionic compounds. And covalent bonds, which are in covalent bonds, form when 2 atoms share their valence electrons. And it's usually between 2 non-metal elements. So ionic compounds have a metal and a nonmetal. Covalent compounds are both nonmetals. And since electrons are shared, there are no charges. Okay, and so some common covalent compounds: water, carbon dioxide, sugar is a common covalent compound. All 3 of these have only nonmetals. And so a single entity is called a molecule. So I might have 3 molecules of water and 2 formula units of salt, right? And so those are how we would use those words. And so they're going to have low melting and boiling points. They do not conduct electricity in water, and they do not dissolve in water easily. And the key word there is easily. I'm not saying that sugar will not dissolve in water, but it will not dissolve as readily, as easily as maybe salt would. And they're going to have low electronegativity differences. And so with this, some elements Some covalent compounds, so some non-metal elements, only exist in nature as pairs, okay? And so these pairs are bonded covalently because they're just bonded with one of the same elements. So they all have this subscript 2 here. And so the way I like to say it is Hofprinkel. I just kind of pronounce it. But another way of remembering them, because you do have to have these memorized, is we know that there are 7 of them. And number 7 on the periodic table is nitrogen. So if you start at number 7 and you kind of look at the shapes of them, or where they are, they kind of make the shape of a 7, and then plus hydrogen, which is way on the other side. So there's 7 diatomic elements. They make a shape of a 7, starting with number 7, nitrogen. That's one way to remember it. And with thinking about ionic versus covalent, that sort of thing, bonding is rarely only covalent or ionic. Just like sometimes you can have something that's red and orange, kind of red, kind of orange. You can have something that's kind of covalent, kind of ionic. It's a spectrum. And so it's determined by calculating the difference, so that means we're going to be subtracting, in bonding atoms' electronegativity values. Okay, so it's those electronegativity values. And so these forces, and by forces we're talking about ionic or covalent, okay, these are intramolecular forces, and that's because they are within the compound. Okay, so within a single element. And so one thing that I kind of want to review is with ionic versus covalent. An ionic compound, for example, if we have lithium and we have fluorine. Lithium is in column 1. It has 1 valence electron, which means it will lose that 1 valence electron to become a cation, right? And so let's pretend this pink dot is its 1 valence electron. Now fluorine has 7 valence electrons because it is in column 17, so it needs to gain 1 electron, and it forms an anion. Well, what happens during an ionic bond is the 1 valence electron from lithium will be transferred from the metal to the nonmetal, and so now lithium will have no valence electrons. It'll have a +1 charge, whereas fluorine will now have 8 valence electrons, which is stable according to the octet rule, and it'll have a -1 charge. And so that attraction between the +1 and the -1 is what creates that ionic bond. But with covalent compounds are a little bit different. It's like water, H2O. Okay, H2O structure looks like this. And so there are a couple key pieces. So these lines here, those represent a covalent bond. Those are electrons shared. And so they represent 2 shared electrons. So each line, 2 electrons. I'll draw them in green. Okay, so it's like those 2 electrons are shared between the oxygen and the hydrogen. And then these electrons are valence electrons still, but they're valence electrons, but they're not bonded. So they're just kind of still out there. They're not participating in bonding at all. And so this is kind of the basics between ionic and covalent compounds. And in the next video, we'll talk about electronegativity differences.